Hello everyone, I'm Jiang Hongzhou. Today I'm going to introduce hacking Adobe Reader through True Typeform. First, let's review a little history. It's about digital typography. Digital typography is about type arranging and designing, which is very important for users to use computer. Basically, it has a very long history, as long as computer. Since the digital typography is so important, many companies try to get involved in the building of digital typography, which includes Apple, Microsoft, Adobe Acrobat. Adobe Acrobat's most important contributions is to digital typography is they invented Type 1 force format, which is the base of all Adobe Reader. Since Adobe Reader is based on Type 1 font format, so if it inherits all of its advantage and disadvantage. If Type 1 font format has bug, then Adobe Reader must have it. As a result, it turns out that there is a bug in Type 1 force, which is blend vulnerability. This bug can defeat all. First, it defeats all of us because we are the user of PDF. Adobe Reader is one of the most common used software. This bug is related to the blend operator, so we call it blend vulnerability. It is inherited by any Adobe readers earlier than these versions. So most of us is in fact influenced by this bug, but we didn't notice it before. And we can overflow the stack with this bug. By overflow, we can use ROP to defeat most of the protections, something like ALSR. So with this bug, we can almost do anything. So what is blend vulnerability? First, we should consider the blend operator. So the blend operators do the thing like that. This operator is used to push block based on the input of n. Also, you will adjust the stack operators based on this formula. N is the input, and the mask design is set by the system. The problem of this operator is that the designer only designs a check for the lower bound, but not for the upper bound. They think n can only be positive. However, if we input a negative number, the stack pointer will increase and overflow the upper bound, which leads to big problem. Because of this, we can explore this operator. So how can we explore this operator? First, create an embedded PDF file. Create a PE-PDF blocklet with a second stage DLL by compiling it in Visual Studio with the start linker options pointing to the PDF file with a valid DOS header pre-painted. Then we craft a payload. Basically, it's a ROP, but many comments are forbidden. But with some special tricks, we can still make it possible to craft a proper payload, which I will introduce after this slide. Then we copy the explore file to this document and call C++ DLL-MAIN function to generate our vulnerable file. So let's talk about how can we craft a payload. So the basic logic of this payload is this 3 point. First, we shift the operand stack pointer so that it points at the interpreter's function's return edges. So it's all about the return edges. And this will triggers an exchange operation, swapping two topmost operand stack entry, which in this case are the stack friend pointer, saved EBP, and the return edges. Finally, use nchairs command to cause the control flow to leave the interpreter, thus triggering a bug check upon attempts to execute data from stack while using the corrupted return edges. So there is some comment limitation here. You can only use not, neck, ABS, squares, index, exchange, delete, add, sub, mount, and get. And the most important is this get, as well as this squid. We can see how can we use it to read or write stack edges. So this is the example. We want to write 31337 to the stack. So the big problem is that there are too many possibilities of the stack edges. We can apply 5 times squares to the edges. And if the edges here is 0, it will return 0. If not, the 16-bit number after 5 times squeeze, the result can only be 1. So it reduces the possibilities. It reduces many possibilities into only 2. It makes the problems much easier. This is the basic structures of this payload. We can see they cause many functions, and it's much more complicated than the RLP we do in our homework. So let's see a demo. This demo is a PDF, which we'll call CMD, something like shell in Windows. So I do it in my a virtual machine, and I installed Windows 7 and Adobe Reader 9, which is a much earlier version than Windows 8.1 and Adobe Reader 11, but I want to make a more promising exploitation, so I just download earlier version. Sorry about that. Let's see. This is an embedded PDF file. If we open it, you will launch a PDF file as well as a CMD. Let's see. Here is a warning. And we open that. Yeah, this is CMD. And this is Hello World. So this is my demo. So how can we protect ourselves from this bug? First, you should update your software in time, because this bug is fixed right after Adobe Readers 11.0.20. And once the bug is reported or published, normally the software company will publish a patch to fix this problem. So try to update them in time. And second, try to refuse any unknown PDF file from unknown source. Yeah, you know, from this presentation, at least you should remember PDF can in fact execute something. So you never know when a hacker will find a new bug. So that's my presentation. Do you have any questions?